Hello everyone. We are doing Level 2 Calculus 2023, question 2C III. I solved this last year, but then I've noticed I made a mistake, so I'm gonna do this again. So this is second take. So question says, a car with a new brake pads is capable of deceleration of 2.5 meters per square second. However, as the car's brakes age, they become less effective at slowing down the car. If an older car's brakes were only able to allow for a deceleration of 2.1 meters per square second, what is the highest speed in which the car should be traveling so that it is able to come to a complete stop in the same distance, approximately 154 meters, as the new car described in part II2? If you haven't, try question 2C, and then you would understand this question better. So first of all, we have to find v of t, isn't it? So from deceleration 2.1, so v of t equals integral negative 2.1 dt, right? And it comes out minus 2.1 t plus c. Now, the reason why I put negative is because it's deceleration, isn't it? So the question here actually is, what is the velocity when the time is naught, isn't it? So that is negative 2.1 t plus, sorry. So I meant times 0 plus c, isn't it? So that is the speed we want. So I'm going to name this one C1. Okay, there is a reason why you will find shortly. So then we have to find displacement function, which is S of t, isn't it? So distance. So we have to integrate velocity, right? So which is minus 2.1 t plus c1 dt, right? Then negative 2.1 t squared over 2 plus c1 t plus c2, right? That constant. However, if we plug 0 into time, c2, so s of naught is c2. That should be 0, isn't it? Because a car, applied the brake and then it halts, it stops here. So this is a reference point, isn't it? So we have to say the distance is 0, and the till here is 154 meters. That's what it means. So C2 is 0. So if I write S of t again, minus 2.1 t squared over 2 plus C1 t, isn't it? Now, what's the time then? How long does that take? I mean, this one. So last year, I remember I used 11.11. I didn't think it carefully. It's not 11.11, is it? So we have to calculate. What it means is when the velocity is 0, isn't it? So when we calculate this, I'm going to rub this out. Yeah, I think I have to rub this out. So, oops. So that means t is how much? C1 over 2.1, isn't it? So we have to plug this into S. So S of C1 over 2.1, which is negative 2.1 times C1 over 2.1. Sorry, my pen is not that good. Squared over 2 plus C1 times C1 over 2.1. All right. if you calculate this, you will have, oops, I will show you how you calculate this. Okay, so you go minus 2.1 times C1 squared over 2.1 squared, isn't it? Over 2 plus C1 squared over 2.1. So which is, I can cancel this out, right? And then 2 goes up. So I have minus C1 squared over 4.2 plus C1 squared over 2.1. So I times by 2 on both sides. Oops. Sorry, I'm gonna write here, eh? So minus C1 squared over 4.2 plus 2C1 squared over 4.2, which is C1 squared over 4.2 is how much? The distance must be 154, right? Now we can find C1, which is the velocity, right? When the driver applied the brake. So C1 squared equals 154 times by 4.2. Hence C1 equals square root, isn't it? Plus minus, but because it's velocity, and going forward, it's got to be positive. So square root of 154 times by 4.2. It comes out 25.4 meter per second should be the answer. Right? I hope you enjoyed this. All right. See you next time. Bye.